Alright, so this is page 110, number 14. It says an open rectangular box is made with a square base, and its capacity is to be 4,000 cubic centimeters. So anytime we hear a capacity, what we should think of is a volume, because that's another way of saying capacity. So in this case, our capacity is 4,000 cubic, not squared, centimeters. I've drawn the rectangular prism here that has the square base. Okay. Okay, hold on. Okay, give me 1 second, Eva. Okay, so basically what we know is that this rectangular prism has a base, but it only has one base because it's an open top, and it tells us to find the length of the side of the base when the amount of material used to make the box is as small as possible. So we're looking to be very efficient with our materials, finding the least amount of product to construct this box, and it says we should ignore flaps. So you know how boxes have flaps that overhang the edges? We're just going to pretend that doesn't have any of these. Okay, so basically if this has a rectangular or a square base, what I know is if I call this A, this is also A, and I'm going to call the height H just because it's what we do. So basically, I can write the volume equation. So if you remember, the volume of a three-dimensional object is the area of the base times the height. So in this case, we end up with A squared times the height, because A times A is A squared, H is the height, and that equals our volume. Well, we know our volume is 4,000, so I'm going to substitute that for our V. Alright, so you might notice we have two variables, and if we're going to be dealing with two variables, we have to have two equations to find both of their values. So the other thing that we can find when we're dealing with 3D objects is surface area. So I'm going to write the surface area equation. So the surface area is the area of every side and base added together. So if we start with the base, we end up having an area of A squared. Okay, and then because this is a rectangular prism that has a square base, every side is going to be equal. And we have four sides. We have this side, and because our base and our height are the same on all of them, okay, we end up having four sides. We'd say 4, and the area of all those sides is A times our height, which is H. So A times H. Alright, so we need to basically differentiate with respect to A or H in this S equation. So I'm going to solve for H here. What? Okay, I'll be right there. So I'm going to divide by A squared on both sides, and that equals H. Because if I solve for A, I'm going to have to plug A into A squared and A, and that's just really messy. So solving for H is a cleaner way to do this, though you could solve for A and that would be fine, except you end up with some gnarly numbers. Okay, so S is equal to A squared plus 4A times 4,000 divided by A squared. Okay, so I'm going to just expand this out. So I end up with 16,000 A divided by A squared. Well, we know from our unit on exponents that this is really A squared plus 16,000. And then we say A to the 1 divided by A to the 2. We subtract our exponents. A to the negative 2. If you did it a different way and got the same answer, that's totally fine. I just kind of went for a basic way. Alright, so I'm going to differentiate now with respect to A. So I end up with 2A minus 16,000 A to the negative 2. Now, since we're finding the minimum possible amount, that still means that I'm finding the tangent's gradient of this value is 0. So I'm going to basically figure out what my A values are. Okay, and I'm going to show you how to do this in a way that, you know, we've done before in class, but just to refresh your mind. So one of the ways we could do this without factoring is we could add 16,000 A to the negative 2 to both sides. Okay, and then we could divide by A to the negative 2 So we have all the a's on one side. So we end up with 16,000 equals 2. And then if you remember again, our quotient property says 1 minus negative 2. That gives us a cubed. Okay, I'm going to solve for a now. So I'm going to divide by 2 on each side. So 8,000 equals a cubed. Okay, so I'm going to take the cube root. Okay, so the cube root of 8,000 is 20. Okay, so now we have our a value. Can you ask Daddy for it, Ava? Okay, so a is 20.